Welcome to this explainer, where we're diving straight into a massive paradigm shift happening right now in software engineering. We are moving away from writing traditional deterministic code to something called vibe coding, using autonomous agents. Today, we're unpacking a definitive 2026 white paper on why this high-velocity, intent-driven development completely shatters our traditional trust models. We're also going to introduce the critical new security architectures that you absolutely need to keep these autonomous digital workers in check.
Here's a quick look at our roadmap for this explainer. 1. Welcome to vibe coding. 2. The 7-pillar security harness. 3. Agentic SecOps. 4. Inside the glass box. 5. Security versus output evaluation. And finally, 6. Measuring enterprise ROI.
All right, Section 1. Welcome to vibe coding and the shift to intent-driven development. So, the era of painstakingly typing out every single line of syntax, it's closing. Developers are now expressing their intent in natural language, essentially giving off a vibe and trusting these highly intelligent systems to translate that intent into working software. But, this triggers the death of old-school trust. In traditional deterministic software, trust was just a simple binary gate. The code compiles, the password works, boom, you're in. But an AI agent has the ambient agency to write code, call APIs, and change environments entirely on its own. You can't just trust it once and walk away. We have to shift to what's called effective trust. This is a continuous dynamic metric that verifies the agent's intent every single millisecond.
Moving on to Section 2, the 7-pillar security harness. This is our external safety envelope.
To actually achieve that continuous trust, I want you to think of an AI agent kind of like a brilliant but highly unpredictable autonomous factory worker. You wouldn't just let them wander around the factory floor blindly pulling levers, right? Instead, you build this unyielding safety envelope. It's a 7-pillar framework that covers infrastructure, data, model, app and runtime, IAM, observability, and governance. Because let's be real, we have to assume the underlying AI will eventually fail or hallucinate. Security can't just live inside the model's brain. It has to be an external harness dictating exactly what the agent can and cannot touch.
Now, integrating these pillars into your daily coding workflows requires a pretty delicate balance. When an agent prioritizes speed over secure design, we shift left by using real-time advisory linters right there in the IDE. This nudges the agent in the right direction without creating friction for the developers. Next, we execute the agent's draft code in a strictly ephemeral sandbox. This mitigates vulnerabilities before they can even spread. Finally, we rely on unyielding CI/CD pipelines to deterministically scan for flaws before anything gets near production. It's basically the perfect logical sequence for balancing high-speed iteration with hard, undeniable security gates.
A massive part of this is how we protect the underlying infrastructure. AI models frequently hallucinate completely fake software packages. And attackers, well, they know this, so they upload real malware under those fake names, a wild technique researchers are calling slopsquatting. To stop an agent from autonomously downloading this malware, we lock them in ephemeral, kernel-level sandboxes using tools like gvisor. Plus, we enforce strict non-interactive egress governance. That means the agent can only fetch data through offline caches or pre-sanitized proxies. It literally blocks the agent from wandering out into the wild public internet. But what happens with identity? If an agent borrows a developer's admin credentials, it instantly becomes a massive liability. It becomes highly susceptible to the confused deputy problem, where hidden prompt injections essentially trick the agent into doing an attacker's dirty work. The fix for this is zero ambient authority. The agent never ever inherits your broad ambient privileges. Instead, it gets unique, just-in-time downscoped tokens that expire the exact millisecond the task is finished. Even with those tight identity controls, contextual authorization for high-stakes actions, like, say, dropping a database table, still requires a human in the loop. The problem is developers often suffer from the "it works, ship it" fallacy. They blindly approve complex AI-generated code that they don't actually understand. To fix this, we use something called the vibe diff. Before any critical action happens, the system translates all that complex generated syntax back into a plain English summary. You read the vibe diff, you understand exactly what the agent is about to do, and then you approve it using a physical hardware MFA key.
Section 3. Agentic SecOps. Let's talk about the red, blue, and green teams.
Because these agents generate and execute logic so incredibly fast, traditional manual security teams literally cannot keep up with evolving threats. I'm talking about invisible Unicode payloads hidden inside open-source repositories that can spread across your files in minutes. So our defense has to become autonomous too. Your red team is now an AI agent injecting adversarial vibes to see if your system can be tricked by poisoned RAG data. The blue team monitors the agent's real-time blast radius using behavioral analytics. But the real game changer? That's the green team. If an anomaly is detected, the green team executes a stateful quarantine to safely freeze the agent, and then it autonomously rewrites the insecure code to patch the vulnerability on the fly. It's a self-healing system.
Section 4. Inside the glass box, where we look at tracing the agent's trajectory.
To actually allow that green team to work its magic, we need total visibility. We have to transition from just monitoring infrastructure to tracking the entire vibe trajectory, using tools like OpenTelemetry. We are mapping the massive cognitive leap from a fuzzy human prompt all the way to a compiled script. Why? Because of intent drift. An agent might start out optimizing a database query, but suddenly its internal chain of thought drifts and it decides to download an unauthorized library. When our observability tools catch this drift, stateful circuit breakers immediately trip. They use version control checkpoints to halt the agent and roll back the changes, totally preserving the environment.
Okay, so we've built the perfect fortress. The agent can't download malware, it can't steal your identity, and it's monitored by AI security teams. But this brings us to a massive pivot question. The agent stayed inside the security boundary, but did it actually build what you asked for?
This brings us to Section 5, Security versus Output Evaluation.
Enterprise vibe coding relies on two equal halves. Security ensures the agent does no harm, but evaluation ensures the agent actually delivers value. And this evaluation is uniquely difficult because of what the white paper calls the under-specification gap. You see, traditional testing requires a rigid specification. But simply saying, hey, make the dashboard load faster is not a rigid test case. The agent has to use its own aesthetic judgment to fill in the operational gaps. So, we need entirely new qualitative frameworks to measure if the agent successfully bridged this divide.
We measure this across several distinct dimensions to evaluate code quality and intent. On the user-facing outside, we ask, did it satisfy intent? Is it functional? Does it look visually correct? And what did it cost? And then on the internal inside, did the agent follow our specific coding conventions? Did it take a sensible trajectory to get there? And if a build failed, did it attempt to self-repair? Measuring these dimensions isn't just about checking if the code compiles. Honestly, the code compiling is just the floor, not the ceiling. We have to evaluate intent satisfaction. Did it actually mean what the human meant? We look at token cost and iteration count. Did it get it right on the very first try, or did the developer have to step in and correct it 8 different times? To practically measure these things, we employed layers of automated testing. For intent alignment and tracking trajectory equality, we use an LLM as judge, where we literally have another model audit the output against the original prompt. For visual correctness, we run rapid browser-based testing using scripts that interact directly with the rendered UI to ensure a button actually does what it's supposed to do. It's a comprehensive, layered approach to auditing the agent's internal reasoning process.
And finally, Section 6, Measuring Enterprise ROI and Enterprise Strategy.
All of these safeguards we've talked about, ephemeral sandboxes, agentic SecOps, multi-dimensional evaluators, they represent a massive investment. So, how does leadership justify deploying these complex frameworks within legacy enterprise environments? It's all about balancing the trade-off. High-velocity vibe coding accelerates innovation incredibly fast, but without the unyielding safety frameworks we've discussed, it introduces unacceptable risk. Corporate leadership has to justify this by proving that the overhead of these security layers is vastly outweighed by the sheer speed and quality of safe, autonomous code generation.
Practically speaking, executives measure the security ROI by looking at session conversions, basically how fast and cheaply an agent reaches a satisfactory result in terms of token costs and developer time. They also rely on this robust 7-pillar architecture to ensure strict compliance with things like the EU AI Act. Culturally, this changes absolutely everything. Developers are no longer just typists writing syntax. Leadership must foster system architect skills, training their teams to become orchestrators who define boundaries, evaluate outputs, and manage these autonomous systems.
Which leaves us right here. The transition from writing syntax to expressing intent isn't some distant future. It is happening right now. A raw AI model is just an engine. It only becomes an enterprise-ready agent when it's wrapped in this exact security and evaluation harness. So I'll leave you with this. As trust shifts from deterministic syntax to dynamic intent, is your enterprise ready to securely evaluate its new autonomous workforce? Thanks for joining me on this explainer, and keep building safely.